Okay, so we had chapter 6.1, the antiderivative.
Antiderivatives are related to definite integral through the fundamental theorem of calculus. The definite integral of a function over an interval is equal to the difference between the values of an antiderivative evaluated at the end point of the interval.
Our first example of an antiderivative is just going to be the anti-power rule. For the normal power rule, your first step is going to be to multiply that a times the n and then subtract the 1 from the exponent at the end. For the antiderivative, you're going to do the exact opposite. First, you're going to add 1 to the exponent, and then you're going to divide by that n plus 1. You're going to divide the a by the n plus 1 to get your final answer.
So for log 1, ln the natural of x equal 1 over x. For antiderivative, you just change the place. It's like 1 over x equal natural log of x. And log base b equal 1 over x natural log of b, which is the same thing. You just have to change the place. For antiderivative, it's 1 over x natural log of b equal log base b to x.
The next section we have is the exponential. For e to the x, that's the easiest one. For the normal derivative rule, it's just e to the x. And same for the antiderivative, it'll just go from e to the x right to e to the x. For b to the x, it does change slightly. Instead of going from b to the x times the natural log of b to the x will instead turn to b to the x over the natural log of b.
So we have one example, which is the power rule. So square root of x equal integral x. So the square root, we just change it to 1/2, and then we add 1 plus 2. We add 1 to the 1 over 2, which will become 3 over 2, and then we divide it by 3 over 2. So like the answer will be 2 divided by 3, x to the power 3 divided by 2 plus c.
Our next example is going to be example of logarithms. We have the integral of 3 over x dx. This one's fairly easy because you're just going to be plugging it into the formula and just following it over to the antiderivative. So you have 3 over x dx. If we look back up to the logarithms section, we can see that 1 over x just turns into the natural log of x. So because it is 3 over x dx, it's actually going to equal 3 natural log of x plus c. The next example is exponential. We have the integral of 3 times 1.2 to the x dx. This is one where we just kind of plug it into the exponential antiderivative formula. So we have 3 times 1.2 to the x, and that 1.2 to the x is going to act like the b to the x. So when you plug it in to the equation, you'll have b to the x over the natural log of b. So your b to the x in this situation is going to be 3 times 1.2, that whole number. So you have 3.12 to the x in the numerator, followed by the natural log of b, which is the natural log of the 1.2. And then, of course, you got to add your c. So just to go back through everything, we have the antiderivative section, the derivative rule. Instead of multiplying and subtracting 1, you're going to add 1 and then divide. For logarithms, natural log of x yields 1 over x is actually going to turn into 1 over x yields the natural log of x. Also, the natural log base b of x yields normally 1 over x natural log of b. Instead, 1 over x natural log of b is going to yield log base b of x. For exponentials, that one's easy. E to the x becomes e to the x, and same for the antiderivative. B to the x yields b to the x times the natural log of b is going to turn into b to the x yields b to the x over natural log of b instead of times natural log of b because it's opposites. Followed by a few examples that you may see on the exam. This is just some of the basic facts or basic things you need to know about the antiderivatives and a few of the basic rules when it comes to power rule, logarithms, or the exponential formulas.